Okay, going to talk, the quadratic formula is another way that you can solve a quadratic equation. Now, we've talked a little bit about a couple different ways. The main way that we've gone over so far, one way to solve is by factoring. Okay, we've briefly just talked about solving it by graphing. That is using the calculator. And then today we're going to talk about the quadratic formula. Okay. So you need to make sure that before you start the quadratic formula, it's in that standard form. Okay, that standard form does include it being equal to 0. So if it's x squared plus 4x equals 8, you would have to subtract the 8 over. Before you plug everything in, you need to be able to identify the a, b, and c. So AJ, in that first problem, what would the a be? What is the a? What's the b? C? Okay. Ethan, on the second one, what's a? What's understood to be in front of x squared?
1.
What's the b?
8.
Negative 8. And what is the c?
10.
Okay. Make sure that whenever you write those, your a, b, and c is not, you will not have x squared or x as part of a and b. Okay. So coming down here, obviously there's the quadratic formula. Now, we're going to get two answers. Let me kind of go off to the side here and talk about this a bit too at the beginning. Whenever we solve a quadratic equation, we are solving for those roots, if you didn't know that, those solutions. So anytime we factor it, that's what we're finding, the solutions. Whenever we do it by the quadratic formula, that's what we'll have. So a lot of times we'll have two different answers. You get that two different answers by the plus and minus. Now, I would highly recommend do not do the whole quadratic formula twice. Okay? We're going to plug it in and use the, we'll have plus minus right there. We'll simplify it down as much as we can until we get to the point where we'll split it off into two answers. Okay, but don't do the whole thing with plus and then do the exact same thing with the minus right there. Just do it once and then we'll split it off towards the end. So let's go down to these two problems. So on number 2, Ryan, what would I need to do before I start the quadratic formula process?
Set equal to 0.
So what would I need to do? What do I need to do with that 1?
Make it negative.
So subtract it. Molly, what's my A?
1.
B?
Negative 4.
C?
Negative 1.
Whenever you substitute the A, B, and C into the quadratic formula, especially if you're one of those that, if you're going to put a big chunk of this into the calculator, put parentheses around it, please. So let's go ahead and take this A, B, and C. We're going to plug it up into the formula up there. So I've got the first negative. That negative belongs to the formula. And then I've got negative 4. That negative belongs to the B value. Plus or minus the square root of b squared minus 4ac all over 2a. All right, please take note as to the process in which I simplify this down. All right, the first thing I'll do is I'll look at the very beginning. Is this 4 going to end up being positive or negative? Positive. Negative times a negative is a positive. So I have 4 plus or minus. What is negative 4 squared?
Negative 16. Actually, positive
16.
16.
Make sure that in your calculator you do not put this and get negative 16 and come screaming at me saying that I'm a liar because the calculator says it's negative 16. Whenever you put it in that way, the calculator is squaring 4, and then it's leaving the 16 on there. Or sorry, the negative on there. Okay? If you're going to square it, you need to square it the whole thing, which is why I emphasize putting parentheses around this. So a lot of times I'll find that real quick, that b squared part, and then I'm going to multiply the negative 4 times the a times the c. Negative 4 times 1 is what? Negative 4. Negative 4 times negative 1 is what? So I have plus 4 over 2. Next step is usually it's pretty easy. A lot of times I will combine these two, and I'll just add what's underneath there. So once I'm here, I need to figure out whether that number underneath the radical is a perfect square or not. Is it?
Yes.
20 is a perfect square?
Or not 20.
No, it is not. Okay? So if it is not a perfect square, what do you think we have to do to it? Someone said in here. Simplify it. What is the largest perfect square I can divide 20 by?
16.
No.
Oh, wait, no, 10. Not 10.
What?
4.
4.
Yeah.
What is the square root, or sorry, what is 20 divided by 4?
5.
Sorry. Yes. 20 divided by 4 is 5. I'm getting ahead of myself. What is the square root of 4? 2. So if it helps you to take that square root of 20, go off to the side, simplify it, and then the next step you'll just go back in and you'll, instead of the square root of 20, we'll now have 2 square roots of 5. So 4 plus or minus 2 square roots of 5 over 2. After this, if you can simplify this, which by simplify, that means you have to be able to divide that and that. Can I divide 4 by 2?
Yes.
Can I divide 2 by 2?
Yes.
Okay. 4 divided by 2 is what? 2 divided by 2 is what? So I can simplify it all the way down to there. And then one of my answers is 2 plus the square root of 5. 2 minus the square root of 5. Which if you were to find the decimals of those, it would be 4.23 and negative 0.23. Now, listen to this real quick. I've had a lot of people who have gotten really good in the past of substituting all that in, putting all of this into the calculator as is, which yes you can do, putting it in there once with plus to get this answer, once with minus to get this answer. And if you're asked for the decimals, then you can do that. But if this is all you have on your paper, and then you have the wrong answer, there's very little room for me to give you any kind of partial credit. If you go through the process here and let's just say that you accidentally pull the 4 out, you forget to take the square root of it, and you put 4 square roots of 5, but you've gotten everything right up till that point, I can give you more credit. So you can do it, yes, but there's a lot of room to make mistakes. For example, somebody saying negative 4 squared is negative 16. It's going to give you the wrong answer, and you're going to get the whole thing wrong. Okay? So next, I want you and all your little buddies around you to attempt number 3. Go through that whole process. Identify A, B, C. Plug them all in. All right? I'll be about a minute or so, maybe behind you, putting those up. If you're getting lost in the process, please raise your hand so that I can. Here's your A, B, and C. And then this is what it should look like once you plug everything in. Once I have that square root of 36, what is that? 6. So if it is a perfect square, that means you will no longer have the radical there. 2 plus or minus 6. These are a lot better than the problem that we just worked out together. So now once I have that, I'm going to do the plus or minus part. 2 plus 6 is what? And 8 over 16 can reduce to 1/2. 2 minus 6 is what? And negative 4 over 16 can reduce to negative 1/4. Okay, let's go to the back. So, looking at this, please pay attention. Okay, so kind of connecting this to the I stuff, all the stuff that we talked about last time. Okay, it says what happens if the number under the radical is negative. In the real number system, there is no such thing as the square root of a negative number, so the complex number system addresses this with the imaginary I. Okay, which last time, and even today at the beginning of class, we talked about I squared, which always equals what? Negative 1. So, what is the square root of 49? 7. So, what is the square root of negative 49? 7i. What is the square root of 121? 11. What is the square root of negative 121? 11i. Yeah, it's like magic, huh? Okay. Let's go down. Let's look. We're just going to look at 6 on this because we've already done some of these even today. In fact, we did this one. We did this one on the first problem, the square root of 20. And that ended up being 2 square roots of 5. And it was positive 20. So the square root of negative 20 would give me what? 2i square roots of 5. You just got to put the I in there. Let's go through the whole process on number 6. What is the largest perfect square I can divide 72 by? 12 is not a perfect square.
64.
And it come out even. 72 divided by 64. There you go. That way to guess and check there, Kendall. Okay. So, since it's negative, I'm going to pull the I out. 72 divided by 36 is what? 2. What is the square root of 36? 6. So I end up with 6i times the square root of 2. So now let's get to the fun problems. Okay? Now, to answer a question that I was already asked today, please listen. Whenever we have these kind of problems, do I always have to use the quadratic formula? Because I can do it in the calculator in about 2 seconds. Whenever you end up with an imaginary solution, you cannot find these in the calculator. So you need to know the process. Okay? So looking at number 1. Connor, what is the A value?
1.
B value?
Negative 10.
C value?
34.
Alright? So I get all that, and please write small on this part. I probably should have allowed more room for these problems. So I'm going to have the negative that belongs to the formula, and then b plus or minus the square root of b squared minus 4ac all over 2a. Let me help y'all out in the back real quick. Is that a little small to read? Is that better? Okay. So the 10 at the very beginning, is that going to end up being positive or negative? Positive. It's a negative times a negative. So 10 plus or minus the square root. What is negative 10 squared? 100 or negative 100? 100. Next, what is negative 4 times 1 times 34? Someone put that in the calculator. Tell me what it is. Negative 136. $100 minus 136 is what? Negative 36. Molly, what is the square root of negative 36? 6i. So I have 10 plus or minus 6i over 2. Kendall, can I divide 10 by 2? Can I divide 6 by 2? Okay. 10 divided by 2 is what? 6 divided by 2 is? So I'm going to have a 5 plus 3i, and I'm going to have a 5 minus 3i. Here's your A, B, and C, and also what it should look like once you've plugged it all in.
I thought it was negative 7.
So once you have it simplified, this is what, okay, once I kind of simplify everything, that right there is what you should get.
And that's it?
So the negative on the 35, what does that become? It becomes I. So I have negative 7 plus or minus I, square roots of 35 over 6. Can I simplify the square root of 35? No. Okay, I start off with the next, below that, the largest perfect square, which is 25. Can't do that, can't do 16, can't do 9, can't do 4. So if I can't divide it by a perfect square, I cannot simplify it. After that, negative 7 divided by 6. Can I reduce that fraction? No. Okay, the previous problem we had 10 divided by 2 and 6 divided by 2. I could do that. I can't do negative 7 divided by 6. So my answer is negative 7 plus I square roots of 35 over 6 and negative 7 minus I square roots of 35 over 6. Okay, this, we will very rarely see an answer as crazy as this, but know that it is possible. A lot of the time, the errors that happen here are you're not for sure whether or not you can go any further. You get to a certain point, you're like, well, sometimes the radical goes away, sometimes it doesn't. Sometimes you simplify it, sometimes you don't. Whenever you get to this, see if you can simplify that, and that's the dividing by the perfect square. If you can't, then you can't. That's fine. Then see if you can reduce the fractions. If you can't, that's fine. Then there's your answer. Okay, questions on this? Yes, AJ.
Why isn't it negative 7i plus? Like, why is the
The I always goes right in front of the radical.
When you take out the negative.
Yes. Any other questions on this? Yes, Anna.
No.
You good? Okay. Okay, so let's go down to the next part of the notes. So with all those, and I don't think this is too complicated, these are roots that they've given us, and they want us to write standard form. Now remember, the roots are in which one of those three forms? Standard, vertex, or factored? Factored. So if my two roots, if on the graph they are at -6 and 4, what does my factored form look like?
X plus 6 and X minus 4.
Okay. So here we've got two roots, and we're putting it into factored form, and then we need to put it in standard form, which we have done before. How do I change that factored form to standard form? FOIL. So I have x squared. This one ends up being plus 2x minus 24. So let's go over to 2 and do it with the imaginary. This does not change. The positive becomes negative, the negative becomes positive. So if I have a root that is positive 2i, what does that look like in the equation? X minus 2i. The negative one looks like what? X plus 2i. And then I just do FOIL, which we did a very similar problem on the homework before we got started on today's notes. I'm just going to do FOIL on this, and then on number 4 I'll show you a shortcut on doing these. So x times x is x squared. What is x times 2i? 2ix. Negative 2i times x is what? Negative 2ix. Negative 2i times 2i is what? Minus negative 4 what? I squared. My 2ix's do what? 2i's x's cancel out. Now I have I squared. What am I going to put in for I squared? And what is negative 4 times negative 1? So there's my equation. Then let's jump down to 4, and then we'll fill in this table after that. So, on 4 you have 3i and negative 3i. Now, please listen. On the equation from the homework, I believe, it would have been 4i and negative 4i, and we got x squared plus 16. So with those two examples, what do you think is a... Someone tell me what you think this the answer on 4 is going to be. X squared plus 9. Okay. If it is one of these with the imaginary roots, and again, the examples we're going to see are like this. 2i, negative 2i. 4i, negative 4i. Negative 3i, 3i. It is going to be x squared plus whatever that number is squared. 3 squared is 9. 4 squared is 16. 2 squared is 4. Okay, so that's kind of a quick, easy way for you to do that. If you forget that shortcut, just do the FOIL that we've been doing almost the whole school year so far. Alright, let's come down here in the quadratic formula, the expression. And this is got left off right here. B squared minus 4AC. What is underneath the radical? It does not include the radical, just what is underneath the radical. This is what is called the discriminant. We can use this to determine how many solutions an equation has and if they are real or imaginary. Okay, there's only 3 possible outcomes. So let's talk about those 3 outcomes. If you find the discriminant, the number underneath the radical, and it is greater than 0, which that is just another way of saying that the number is what? If something is greater than 0, it is positive. Okay, so right here we're just talking about positive numbers. Which we did on the very front, number 2 and 3. How many answers did we get? On the front, problems number 2 and 3. How many answers did we get on each one of those? 2. Were they real or imaginary? Did they have I on them? No, so they're real. An example of what that is going to look like is a parabola that crosses the x-axis twice. There's your 2 real solutions. They exist. They actually do cross the x-axis. If you find the discriminant and it comes out to be 0, and let's kind of think about the math doing the whole quadratic formula here. If I end up with 0 underneath the radical, what is the square root of 0? 0. If I add 0 or subtract 0, if I add 0 and then I subtract 0, am I going to get 2 different answers there? No, 4 plus 0 is 4, 4 minus 0 is 4. So you're only going to get 1 real answer there. And now think about that graph. What is that graph going to look like if it just has 1 real solution? It's not going to be a straight line. You'll still have a parabola.
Just sideways.
Do what, Joey?
Exponential.
No.
It looks like this then, right?
No.
Or was it the other one?
Possibly, yes.
Is it sideways?
But kind of define it. No, it's not sideways.
One of the parts of the parabola is on the axis.
Do what?
It's on the x-axis, the y-axis.
No, not necessarily. What it will look like, and some of you are kind of getting around it, and you might have been thinking this, I just wasn't understanding what you're saying. It's a parabola that just goes down, touches the x-axis, and comes back up. Okay, so it's only touching it once. It's only going through it once. If the discriminant b squared minus 4ac is less than 0, which that is another way of saying that the discriminant is negative, which on the examples that we did on this side of the notes, up above, or sorry, I think it's on the bottom of the last page, how many answers did we get? 2. Were they imaginary or real? Imaginary. Now I want you to put imaginary / complex. And so what would that parabola look like? It could be upside down. It just doesn't cross the x-axis. So it's something like that.